Good morning, Britain. I look super pretty because I'm filming on Cassie's amazing camera. I'm super excited. Also, today was SUMS, or well, yesterday was SUMS because I'm not going to post this until tomorrow. SUMS is the Shenandoah Undergraduate Mathematics and Statistics Conference at James Madison University in Harrisonburg, Virginia, which was super fun. They will hopefully do it again next year because I love and adore SUMS. I went last year. I'm going this year. I can't go next year because I'm not going to be in the area and I'm not going to be an undergraduate anymore, but like, it is such a great place for meeting and networking with other students and teachers, and also for being able to share your research and have a chance to present in an environment that is very open and welcoming because it's just other students being like, yeah bro, you worked hard on this research. Props for you. But it was super fun and I really love it, and apparently the Mathematical Association of America has drawn back their funding from SUMS because they funded it last year but it wasn't funded by them this year despite my flashlights from them. If you, person watching this, happen to be from the Mathematical Association of America, y'all should fund SUMS again because SUMS is amazing. And I got some super cool stuff which I'm going to show you right now. This is my bag of super cool stuff. See? Ooh, what's in the box? I know what's in the box. Do you know what's in the box? Huh? I got the water bottle and it is bright green. So I got these keychains. They look really cool. A bunch of cool pencils. Can you see this? I got I Heart Math pencils. Then I got a cool pen. And then I also got 3 Japanese puzzle books, which are pretty cool. Puzzles. Also at SUMS I got super cool stickers. The D20 is the SUMS symbol thing, so I got a sticker version and then I got a decal version. I got some notes on what I should put in my personal statement from this cool panel on grad school, which was awesome. But also at SUMS, so Mimi and Shayna were presenting, which was super awesome. Shayna transferred in this year and so she's a math major. She's amazing. And they both did great jobs. Props to both of you. And there was this one poster during the poster session that was so cool. It was this girl, so it was a high school girl and a college girl, and they work together and they are using quadcopters and some math and stuff to help stop poaching of elephants in Africa. And so the high schoolers actually been down to Africa and they're actually working with people in Africa to try and get the quadcopters up and running, and they're just like super cheap quadcopters to try and help park rangers be like, hey, there's a poacher over here because so many elephants die every day, oh my god. Which is bad because we like elephants. We like elephants a lot. So that was really cool poster. And then I looked at some of the other posters too, but that was the main one that I was like, yes, yes. And then I went to a seasonal matrix model for growth of Lycium carolinum, which is a berry plant that this girl modeled the growth of it using matrices because it's the main food source of whooping cranes after they migrate from Canada down to that area, which was super cool that she got to do that for her. She did it for an REU over the summer and I was like, yes girl, yes. Get it. After that was Shayna's talk, which was super cool. I didn't really understand most of it. Like, I got the basics of it, sort of, but I still managed to ask some pretty cool questions. And actually, one of the professors from JMU that was at the talk, he was like, that was a really good question that you asked. Because, so Shayna's talk was omega complexity in chaotic systems, and so it's complexity of chaotic systems, which I don't feel like explaining because I don't really understand them. But basically, they can be used to model and like map neural pathways of like schizophrenia patients, which I thought was really cool. And so my question was whether or not they are used in psychology to see how well omega complexity works in measuring and looking at the differences between schizophrenia patients and before and after medication while they're on their medication, and the differences in medication, because I thought that would be really cool. But Shannon didn't know because she's a math person, not a psychology person, so she was just looking at the math and just knew of that application, that it was applicable. Oh, after that I went to the career and industry panel, which wasn't super helpful because it was mainly talking about like math and computer science careers, which I want to do economic research. But I talked to another professor, another JMU math professor, about doing research and stuff and going into grad school, and so she gave me some tips and stuff, and I was like, thank you, friend. Although I felt super awkward because thank you, friend, and stuff like that is how I interact with most people, and so I wasn't being like super professional when I was talking to her, and so I used some slang terms that she didn't quite understand, and I was like, oops, sorry, I gotta be professional, oh crap. And so, but I think she thought I was cool. I thought she was cool. And then after that, we stole some cookies and drove home. So, for Anna, that is all that I have for you today, and this video is going to be super freaking long, but that's okay because I'm talking about math, and math is amazing. Finger guns, and I will see you whenever you make a video because I called you earlier and you said you were going to make one, but I love you. Goodbye.